So these are my slides about Santilli's telescope, and what you see with Santilli's telescope when you look at the night sky is some anomalies. You're seeing things which you don't normally see with a normal telescope. So I've got a video of this talk, so I'll try adding that to the stage now, saving the voice. I might try to add the talk I already gave. So it's in the wrong place at the moment, so I just sort of try again. Share screen. This video presentation is on Santilli's telescope, Astronomical Anomalies. So what we have is there are two types of light: ordinary light, which we are familiar with, and a second type of light called Isodual light. Isodual light bends in the opposite way to ordinary light and has different properties to ordinary light. Normal astronomical observations have been set up the way Galileo telescope was set up to deal with ordinary light. Santilli's telescope is set up to work with isodual light. There are objects in the sky that emit only isodual light and so are invisible to telescopes that have been set up to deal with only ordinary light. Comparisons are then made between astronomical observation made with a Galileo telescope with a Santilli telescope. The consequences, of course, are that much which is said in mainstream physics is wrong. So I'll be going into more details about that if any of that didn't make sense. This is a picture of Santilli and his telescope. Ruggiero Santilli is studied physics at the University of Naples and earned his PhD in physics from the University of Turin. And basically he has ideas which are deemed heresy to much of the mainstream. This is a good short video going into a bit more details about what's going on with the telescope. So claims are made being able to detect antimatter entities with this Santilli telescope in the night sky. This is an ordinary telescope, Galileo telescope. It focuses ordinary light, which we are used to, and it uses a convex lens to focus it, and it does not focus isodual light. Isodual light diverges for convex lenses. Ordinary light follows a certain geometry, and isodual means follows a different geometry. And I give the definition there of isodual, which you can look up from Thesaurus. While a Santilli telescope focuses isodual light, it's done with a concave lens. A concave lens does not focus ordinary light. So the geometry is convex lens converges ordinary light, concave lens diverges ordinary light, while we have a different geometry of a convex lens diverges isodual light, and the concave lens converges isodual light. People also ask, is congruent meaning equal? The word congruent means exactly equal in terms of shape and size. Even when we turn, flip, or rotate the shapes, they remain equal. So the two types of light are congruent because you can flip one to the other. Everything seems to be set up for instruments, equipment, etc., to deal with ordinary light. So there are technical problems with dealing with isodual light, but basically that is what it is. Convex lens to focus ordinary light, concave lens to focus isodual light. If a light emitting source is purely isodual light, then it's invisible, undetected by an ordinary Galileo telescope. So when comparisons of images from a Galileo telescope with the Santilli telescope, they are not the same thing. What we have in the night sky is alien ET megastructures that are invisible to ordinary Galileo telescopes. So how come this has been missed? Well, we got our understanding of antimatter wrong. So the idea of antimatter goes back basically to this person. It's Paul Dirac. He was an English mathematical and theoretical physicist who was considered to be one of the founders of quantum mechanics. Dirac laid the foundations of both quantum electrodynamics and quantum field theory. So basically, the revolution in physics was quantum physics and Einstein's relativity, and this was back in roughly the 1920s, and Paul Dirac extended that to further with what became quantum electrodynamics and quantum field theory. And he came up with these things like antimatter. So what he did is he picked up things from this equation from Einstein. When P, which is momentum, is 0, we have the equation E equals mc squared. And that's famously attributed to Einstein, but if you look in the history, there's other people who were saying similar things. Anyway, E is the energy, m is the mass, and c is the speed of light, which has been deemed constant, and that constant is arguable. When p does not equal 0, the equation is a bit longer. It's written out like this. It's E squared is equal to, open brackets, mc squared, close brackets, and that's squared, plus open bracket, pc, close bracket, squared. And the thing to note is have E squared. And so you have this energy squared is E squared. If you take the square root of this, then most people would say the answer is E. But that is only the positive solution. Actually have a negative solution as well. So you have the square root as being a positive plus E and a negative minus E. So positive E times a positive E equals E squared, whereas a negative C times a negative C is equal to E squared as well. So you have positive and negative energy from the energy equation of shown earlier. And by convention, physicists usually take the positive solution and ignore the negative solution, so they only deal with positive E. They only deal with positive energy from that equation. Thus, when thinking in terms of matter particle and antimatter particle, such as the electron and anti-electron, the electron has a negative charge, and the antimatter particle, equivalent to the anti-electron, has a positive charge. And they've been thinking in terms of both having positive energy, which is plus E. Really should have been thinking in terms of a particle with positive energy plus E, and antiparticle with negative energy minus E. Thus have got matter and antimatter wrong, and thus got light wrong when talking in terms of photon and antiphoton. So this whole idea of matter and antimatter has been messed up, and when it comes to doing their experiments, they're thinking in terms of antimatter still being positive energy along with ordinary matter. And the problem then being they've messed up the use of words. So thus, to compensate for them having messed up their terms, they've messed up the way they talk about matter and antimatter, we have to talk instead in terms of ordinary light and isodual light. So light bends under gravity like this, putting aside other things like Ed Dowdy, who wants to talk about those things differently. While isodual light bends the other way. And it's similarly for things like lenses. You've got a convex lens, ordinary light is being bent towards the focal point, while isodual light is bent the other way. The focus of thinking by people has been to only concern themselves with the light that can be focused, the ordinary light, by convex lenses, and ignore the isodual light. Hence, everything set up to deal with ordinary light, and thus presented with technical difficulties with existing instruments that have been set up for ordinary light, trying to deal with isodual light. Now, I was taught this at an elementary level in physics. That's the red line, it's representing light. And forget this line for the moment, the one shown going upwards to the right. The red line is the light going from one medium to another medium, and is bent as it goes from one medium to the other. But there's also this light which bends the other way. We are told to ignore that, but that is the isodual light. So what we have is, when we've got the light source, it starts off as a mix of ordinary light and isodual light. When it hits the medium, ordinary light gets bent one way and isodual light gets bent the other way. Thus, we've been making incomplete astronomical observations from the very beginning, when Galileo started making them. I'll be dealing with astronomy in this video, but the same sort of issue applies with the microscopic. That he messed up about dealing with observations using light. Thus, we've been missing images like this. This is a triangle that arguably could be an alien stroke ET megastructure. This is an image taken using a concave lens. So here's some images. We're now comparing a concave lens against what you would observe with a convex lens. And so they're looking quite different, these images. And so more images that are looking quite different from what you get from using a convex lens compared to what you get with a concave lens. And there's some more images showing the same sort of differences you'd get. Looking closer at one particular image, you can see using convex lens and a concave lens, you're getting different looking structures going on. Conclusions. Basically got everything wrong in our understanding of light, gravity, etc. And so the mainstream, what they do is just keep sweeping certain things under their carpet. They have what is called confirmation bias, tendency to search for and interpret and favour and record information in a way that confirms or support one's prior beliefs and exclude other information. So what they've been doing is they've got their bias towards ordinary light, and they've been ignoring isodual light. They don't even recognize that isodual light exists most of the time. So thank you. That's the end of this little video. Thank you. So hello, back again. Let's see. Remove that one. I've got several videos which would help clarify things a bit more. So I'm just trying to work out what's what here. Yeah, so 2 more videos. I should have had them on. Share screen. Good. Play this one. Here we go.
This week's BTV Spotlight features Thunder Energies with the world's first telescope to see galaxy antimatter. Antimatter could pose a global threat because it reacts explosively on contact with matter. Just half a gram of antimatter would be the equivalent of an atomic bomb.
The revolutionary Santilli telescope enables the astronomer for the first time to be able to detect antimatter.
Refractive telescopes have convex lenses. Our telescopes are the only one available with concave lenses for the first detection of antimatter galaxies.
We have working prototypes. Thunder Energies is ready to bring our telescope to market. We're dedicated to bringing tomorrow's technology into being today by producing the world's first telescope capable of detecting antimatter.
Go online for the full interview.
This is called a Shishibo cube, and let me show you what it does.
let's play this video and see if it clarifies things. So I think I made that my last video to show you. Just move things a little bit. I'll first emphasise that it's ordinary light is going to bend that way, and isodual light is going to bend the other way. So what you've got here is things with anti-gravity as well. So that's sort of like an anti-gravity effect. Go back to Word. So this is basically what it is. You've got ordinary light, and what you've got is congruent to that is isodual light, and that isodual light has been missed by the mainstream. They've been ignoring it. Sort of like don't even give it a name. So you've got two types of light, and you've got isodual light that's being ignored and not even named by the mainstream. And when it comes to optical equipment, what they have is trying to focus ordinary light, and this isodual light, which they haven't named, they're just seeing as a inconvenience, and so they're trying to filter that out of their optical equipment, and it's particularly bad in digital cameras. Digital cameras are designed to work with ordinary light and to try to filter out isodual light. So it's a difficult effect to reproduce now that we've designed our optical equipment to work with ordinary light. And so that's one of the areas which sets people off arguing, because they sort of like, try to duplicate it sometimes and they have difficulty. So basically setting off from Galileo. Galileo made these amazing astronomical observations, and people then eventually, after he had problems with the Inquisition and so forth, people started focusing on his methods of making astronomical observations. And so they focused on improving the technique he was using to see these astronomical bodies and so forth. And so they focused on that method, and they didn't realise that there was another method you should be using with light, namely using Isodual light. So it's been completely, well, almost completely missed since then, until Santilli has brought it more into our attention. And when you start making these astronomical observations with this different type of telescope, when you're seeing things like that, you kind of like, well, that's not, you don't see that with an ordinary telescope, which is that sort of thing is invisible to an ordinary telescope. And so you immediately start thinking it must be aliens. Things like that must be aliens, or sort of like it must be an alien megastructure. And if you look online, there are people who go back to the times, I think, of science fiction, early science fiction, where they have these ideas of alien megastructures, such things as a Dyson sphere. So in science fiction, they've already had this idea that there are very advanced alien civilizations out there that make these giant structures in space. And so it's very weird that our telescopes have been geared up and designed to filter out being able to see things like that. So it's quite a breakthrough revolution if we accept that this new astronomical technique, and of course it would be arguable whether it is alien megastructures or whether we can explain these things by other ways. But basically it's the same sort of thing in the revolution in science when Galileo came along with his telescope and we started pointing out these strange things in the heavens, which eventually led to Newtonian physics and the abandonment of the old physics of the time, which was Aristotelian physics. So maybe this means we need a total revolution now in physics, particularly Einstein's relativity has not taken this effect into account. Einstein has been dealing with light, and it's always been ordinary light. It hasn't been dealing with this other light, Isodual light. And so in the context of a theory which has both ordinary light and Isodual light, well, Einstein wasn't writing anything about such a theory, so it goes beyond what Einstein's saying. So we go back to Santilli. So Professor Santilli has been arguing a lot with people about this. And what you've got there is two telescopes. One of them is called the Galileo telescope, and that's set up to deal with ordinary light. And the second telescope is his Santilli telescope. And what you do is you compare observations of the Galileo telescope with the Santilli telescope. And so that is basically it. The same sort of revolution we had with Galileo. Suddenly we seem to have a need for another one with these new astronomical observations. Of course, introducing this leads to people start arguing over what it means, because when Galileo gave his astronomical observations, it wasn't an easy transition from the old physics to the new physics. It involved a lot of arguing. And that's basically the end of this talk, and we can now go to questions. Today, it's something to do with America's Thanksgiving Day. I think most of the people who are in John Chappell natural philosophy are Americans, and so the Americans haven't turned up in the what is the green room to ask any questions, and that could mean this is going to be a short session without any questions from the rest of the people in Chappell natural philosophy. And it's probably one of the reasons why I was given this slot to give a talk, because nobody else wanted this particular slot. They were all going to be off enjoying themselves and celebrating with their family and so forth. So, but anyway, we can look at if there's any questions in the chat. Let's see if I try to call up my chat comments. So we've got a lot of people in the chat. If anybody's in the chat and they want to join, go into the green room, they can do so. Let's see. Don't know how far back to go in these chats. These people, they start forming their private conversations between each other. So one of the first comments is, question, is anybody familiar with Santilli's telescope and the different types of light? Question mark. Well, hopefully I've explained that to some extent. If you want to, there's a great many papers written by Professor Santilli on his astronomical observations. And so there are many of them. And so John Hodge says, I read the papers, presumably he's referring to Santilli's papers, and so he's probably familiar with that idea of Santilli. So this question is going off on a different topic. It's not sticking to what I've been talking about next. So Cornelius hasn't heard of the Santilli telescope either. So were they convincing? Control data. So John Hodge thought I think it's referred to Santilli's papers, and he didn't find the papers very convincing. Well, hopefully I've explained Santilli's observations better in the context of that. What Santilli has found out is that the mainstream point of view on antimatter is wrong, basically. This is going beyond what the mainstream deals with. You've got to flip things around, so maybe that's part of the problem. And as to control data, don't know. so much. I've shown images of what the Galileo telescope gets and compared it to what the Santilli telescope gets, and so that's in a sense controlled data. And what I understand now is there is a lot more people who are duplicating the same results that Santilli has got with his observations. The problem though is that when people try to duplicate Santilli's observations, as I pointed out, the most optical equipment is set up to deal only with ordinary light and not with isodual light, so there are technical difficulties for trying to duplicate this. So the people who have managed to get the same sort of results as Santilli have had to overcome problems, technical problems. Hello to each one of the people. What does control data mean? Coffee. I have no idea what this guy is saying, so it might be referring to me, it might be referring to other people that have been talking in the videos. So, I have problems with the show presenter. Maybe they don't understand my accent. Is this a new discovery? Well, Santilli has been talking about it for quite some time, I think more than 10 years. So it's only just really taken off with people checking what he's saying and finding that they're coming to similar to what Santilli was getting in the timeline. Yes, Holton Art is a controversial astronomer. He's sort of like heresy as well. That's another topic. So how is ordinary light different than isodual light? Well, have I explained it? They are congruent. But I hope I've explained that properly about it's the differences of the lenses. I can really think of 7 types of matter groups that produce light. Well, as I say, they've the mainstream have misunderstood light. They've not really taken into account this. These 2 types of light which are congruent, and so they've been focused on one thing and missed the other. Yeah, that's it. The antimatter emits different light. The problem there is that mainstream have misunderstood antimatter. So what Santilli means is the proper antimatter emits isodual light, but mainstream have messed up what they think is antimatter, and so you've got a problem there with mainstream again. They've got antimatter wrong. Yeah, sure, mixed. Oh, so you need to speak up. I'm so sure it sounds like you're mumbling. Well, sorry about that. That sounds all right to me. If you can just turn up your volume. Let's see. The problem is I am just here talking to myself at the moment, and there's nobody in the green room to tell me if they can hear me properly. So, unfortunately, it is left to you, the viewers, on Facebook or YouTube or whatever, to turn up your own volume. Yeah, so somebody has their old computer's got a problem with the volume. Sure. Some types of frequency, some types of frequency. I don't know what you're talking about, obvious. It's a diversion. I can hear myself, so that's good enough for me. It says it's not been proven. Well, it's in the process of being proven. If I go to YouTube, I'll have a look to see whether I can hear myself on that. Hold on a moment. So I can hear myself all right on YouTube. I've just come to check, so people who are having problems hearing me, presumably you need to put up your volume. I'm talking at a volume which I can consider good. As I say, there's nobody in the green room who can say otherwise. Yeah. So somebody else thinks that what Santilli has shown has been disproven, but that's false. People may coming forward to check these astronomical observations. It says Isodual light bends in the opposite way to ordinary light. Yeah, that's it. Ordinary light goes in a straight line, with the possible exception of the alleged proof of deflected starlight. Now, it's well, ordinary light is supposed to go in a straight line, unless there's something there going to make it bend. And with there being two types of light which are congruent, one type of light is going to bend one way, and the Isodual light is going to bend the other way. So people haven't appreciated that light can be congruent. How could the lens bend the light though? Well, that's if you're talking about the Isodual light, it's being bent by the lens in a different way to ordinary light. So you would need a theory which would take that into account. But at the moment, existing theories are based on believing there's only ordinary light. So they're only talking about light which bends in one particular way, and not bends in a congruent way. So you would need a completely different physics theory to replace what we've got at the moment. Don't know what that means. Wow. He's giving a well-rounded presentation. Excellent. Somebody likes me. And so I think the other people were trying to understand things from their existing beliefs based on ordinary light. And ordinary light, we are quite familiar with how it bends with lenses. And it needs a flip in the way you think to understand that there is congruent light to that. And the Isodual light doesn't bend the same way as what we are used to. So I think people here are having difficulties trying to fit in to their thinking process that I believe in ordinary light. How can there be a light which does the opposite to what I'm used to? And so they have problems with that, and hence they're trying to reject it. But basically, I pointed out a lot of the problem goes back to their understanding of matter and antimatter, and they got that wrong before them. It's all wrong what they think about matter and antimatter, and so what they're thinking about in terms of light, that's wrong as well. Yeah, that's what Santilli claims. Isodual light is emitted by antimatter. And we've got to realise that the mainstream got antimatter wrong.